Alright. A block of mass m moves on a horizontal surface. When the block has a speed v, the end of the spring, with a spring constant k, is at a distance d from the block. Assume the block is still moving when it's contact with the spring. Part A. If there's no friction on the horizontal surface, determine how much the spring will compress. So for part A, it's pretty simple. Since there's no friction on the horizontal surface, so the work done by friction will not cancel any energy the block originally have when it's moving at a constant speed v. So simply we can just write 1 half mv squared is equal to when the block suddenly touch to the string, right? It still has a velocity of v. And after the spring is compressed, like this much of distance, the block will stop moving. And at that moment, the block only has a spring potential energy, which is half k times delta x squared. So easily we can get delta x is equal to square root of mv squared over k. You will pick the positive solution here because it asks you how much the spring is compressed. So it's actually asking you for the magnitude, not the displacement. So you actually pick the positive value here. So this is your answer for part A. Now for part B. If the horizontal surface now has a kinetic friction with a coefficient of mu, 1. The instantaneous speed of the block at a moment of contact with the spring. So now it's basically the same thing, but now friction actually does some work to cancel out the initial energy or the initial kinetic energy that the object has. So initially, the block has a kinetic energy of one half m times v squared minus when it's on the ground level, right? The normal force is just equal to the gravitational force, and the gravitational force is just equal to mg minus mg times mu times d, and it's equal to 1 half m times v1 squared. This v1 is not the same v as the previous one because that's the new speed when after the block has traveled the distance d along the horizontal surface. So after simplify it, we will get v1 is equal to square root of v squared minus 2g times mu times d. Part 2. Write an equation for calculating how much the spring is compressed. You don't need to solve it. So still, the original amount of energy the block has is just 1 half mv squared, right? Because it's moving at a horizontal surface with a constant velocity of v minus work done by the friction. And after that, it's supposed to be equal to 1 half k times delta x squared. As you can mention that I actually leave some space blank here because you actually forgot about something. When the spring is compressed, the block is still moving along the rough surface for this much of distance. It's actually delta x. I forgot there's a square here. So you should actually, on the left side of the equation, you should actually minus the amount of work, friction done in this part of the section. So we can write minus work done by the friction, part 2. So for work done by the friction originally, we can just use the stuff we get from the last one, 1 half mv squared minus mg mu times d minus the friction force is still the same, right? when it's traveling in this section, it's still mg times mu. And over here, so it will be mg times mu times delta x. And it is equal to 1/2 k times delta x squared. So because the reason that you don't need to solve it, you can just stop right here. But if it actually asks you how to solve it, I'll just tell you a way to solve it. Because as you can see, you're trying to solve for delta x, right? You're trying to solve for delta x. So you can actually reorder the entire function to be a quadratic function and using the formula for calculating the roots of the quadratic function, which is x is equal to 2a negative b plus or minus square root of b squared minus 4ac. You can just solve it in this way, but this will 100% not be on your AP test, so you don't need to worry about it. You can just stop right there.